compound angle formulas, that's what we're going to create today. To start off with, I'm just going to draw in the unit circle. There it is, radius 1. Now, if I want to find coordinates of that point there, or any point on the circle, I can create a right angled triangle there and work out its coordinates. Let's say that angle there is beta. And using trig, we can say, well, x will end up being the cosine of whatever angle that is, cosine of beta. The y value will be the sine of whatever beta is. So there's its coordinates, cosine beta, sine beta. Now, I could have put P anywhere. That's where I place it. I might have placed it over there. Let's call that point Q. And that angle is going to be alpha. So it would have coordinates cos alpha, sine alpha. Whatever angle it makes with that x-axis, that will determine the coordinates. What I'm now interested in is the distance between those 2 points. How can we find it? I could again use trig. I could use the cosine rule. So pq squared would be 1 squared plus 1 squared minus 2 times 1 times 1. The cosine of whatever the difference of those two angles are. Alpha minus beta would be the angle inside that triangle. Tidying that up, we just get 2 minus 2 cos alpha minus beta. I could have done it by coordinate geometry. We have a distance formula. And I would have said, well, pq squared would be cos alpha minus cos beta squared plus sine alpha minus sine beta squared. The x coordinate squared plus the y coordinate squared. Expanding all that out, and we notice, well, hang on, we've got some cos squareds plus sine squareds there. We know that they are equal to 1, so I can tidy that one up to be 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. Now, why on earth was I interested in that distance? Actually, I'm not. I'm more interested that those two things have to be the same. They both came up as expressions for pq squared. So I now know that 2 minus 2 cos alpha minus beta is 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. From there we get the first of our compound angle formulas. You see, we can't expand trig out like we do in algebra. We can't just say cos alpha minus beta is cos alpha minus cos beta. It doesn't work that way. This is the formula we have to use. Cos alpha cos beta plus sine alpha sine beta. Now we can play around with this formula to create one for alpha plus beta. If I replace the beta with a negative beta, then it will become cos alpha plus beta. But then I've replaced it in the right hand side as well. But if I take advantage of odd and even functions, remember the cos of negative beta is the same as cos beta because it's an even function. And the sine of negative beta, well, that's negative sine beta because it was an odd function. And I end up with this formula. Cos alpha plus beta is cos alpha cos beta minus sine alpha sine beta. And you will notice they are very similar formulas. It's just that the signs change around. And you'll notice it's also the opposite sign. When it was plus in the first one, it was minus on the right hand side. When it was minus in the first one, it's plus on the right hand side, which brings me to how I remember it. So here's the formula. I remember it like this. Cos, cos, sine, sine. That's the pattern. Cos, cos, sine, sine. Because there it is. Cos, cos, sine, sine. And then what I say to myself is, well, if it's not the sine, as in not the sine ratio, it's not. It's the cosine ratio. So if it's not that sine, then it's not the sine. So I don't use the same sign, I change it. So if it was plus, I change it to minus. If it's minus, I change it to plus. So in my head, that's how I remember the formula. Cos, cos, sine, sine. If it's not the sine, it's not the sine. Now, I'm going to go back to that original one we worked with, and I'm going to replace alpha with 90 minus alpha. So the formula now becomes this. The cos of 90 minus alpha minus beta is cos 90 minus alpha cos beta plus sine 90 minus alpha sine beta. But we can play around with this because cosine and sine are complementary ratios. So on the right hand side, all of those 90 minus alphas will change to the complementary ratio. But on the left hand side, I can also make that 90 minus an angle. The angle happens to be alpha plus beta. So it becomes sine of alpha plus beta is sine alpha cos beta plus cos alpha sine beta. Let's create one for alpha minus beta. So again, we'll replace beta with negative beta. Let's see what happens. So sine alpha minus beta, sine alpha cos negative beta, plus cos alpha sine negative beta. Once again, take advantage of odd and even functions. And so sine alpha minus beta is sine alpha cos beta minus cos alpha sine beta. Once again, we notice very similar formulas, but this time, when it's negative in the first one, it is also negative on the right-hand side. And when it was positive in the first one, it's also positive on the right-hand side. So the way we remember this one, sine becomes sine cos cos sine. So sine cos cos sine. And this time, if it's the sine, because it is the sine ratio this time, then it's the sine. So the sign doesn't change. So the cosine one, cos cos sine sine. If it's not the sine, it's not the sine. And then for the sine one, we go sine cos cos sine. If it's the sine, it's the sine. So how do we remember this? Remember, whenever you say cos, you say cos. So if I go back to the cosine one, so whenever you say cos, you say cos. So I want the cos ratio. Well, I always start with what I'm doing. So if it's the cos one, I'm going to start with cos. So I go cos, or whenever I say cos, I say cos. So cos cos, that means I must be left with sine sine, because I've got to say four things. Two of them have got to be sine, two of them have got to be cos. So cos goes cos cos sine sine. If it's not the sine, it's not the sine. Whereas sine, so now I start with sine, because that's the one I'm dealing with. Sine, cos, I just said cos, so I say cos again. Cos cos, sine. Sine cos cos sine. Alright, tan. Well, tan I can rewrite. Tan is sine on cos. And we just created formulas for sine and cos. So on the top I've got sine, sine cos cos sine. If it's the sine, it's the sine. And on the bottom I've got cosine. So cos cos sine sine. If it's not the sine, it's not the sine. I'm going to simplify this by making it look more complicated. There we go. I'm going to divide everything by cos alpha cos beta. Now why do that? Because there's now a lot of cancelling that will happen. Notice on the top of the fraction, cos beta will cancel with cos beta. The second fraction, the cos alpha will cancel with the cos alpha, and so on, leaving me with sine on cos, which is tan. And so we get tan alpha plus beta is tan alpha plus tan beta on 1 minus tan alpha tan beta. Let's see what happens when we replace it with negative beta and create a formula for tan alpha minus beta. Well, tan, that is also an odd function. So we end up with tan alpha minus tan beta on 1 plus tan alpha plus tan beta. Again, very similar. Tan plus tan on 1 minus tan tan. So I just remember the positive one for that one. And then I know, well, if it's the negative one, I just change the signs around. So tan plus tan on 1 minus tan tan. There it is. Tan plus tan on 1 minus tan tan. And they are our three compound angle formulas. So compound angle formula. We have sine. Sine cos cos sine. If it's the sine, it's the sine. We have cosine, cos cos sine sine. If it's not the sine, it's not the sine. And we have tan. Tan plus tan on 1 minus tan tan. Let's do some examples. Expand cos of 2 alpha minus 3 beta. So as I say, we want to expand these out. We can't do it like algebra and just go, oh, that's cos 2 alpha minus cos 3 beta. Cosine. Cos cos sine sine. Bang, there's my answer. Cos cos sine sine. If it's not the sine, it's not the sine. So I'll put a plus in the middle. Simplify this, but I notice it has the pattern. Tan plus tan on 1 minus tan tan. So that must be the tan of 20 plus 10. Tan of 30, we know that one. Tan of 30 is 1 on root 3. Find the exact value of sine 15. So what we now need to do is rewrite 15 as either the sum of two angles or the difference of two angles. There's different ways we could do it. I could go 60 minus 45. Yes, I could go 60 minus 45. I did 45 minus 30. There's different ways we could come up with 15. But the key is we want to use numbers that we know the answer to. And we have exact values for 45 and 30. So sine cos, cos sine. If it's the sine, it's the sine. Now I'll substitute in my exact values that I know for those, tidy it up, and there's an answer. Root 3 minus 1 on 2 root 2. They've given us the ratio for the sine of alpha and the cosine of beta, and they want us to find the sine of alpha plus beta. Now sure, I guess it's possible to go and find the actual angle alpha and the actual angle beta, add those two together, and then find the sine of that. But if I don't turn into exact values, we're going to get approximation mistakes. We don't actually need to know what the angles are to solve this problem. If I draw a triangle up for each of these, they're not in the same triangle. So alpha, sine ratio 2 on 3, bit of Pythagoras, other side's root 5. Draw a triangle up for beta, 1 on 4, Pythagoras tells me it's root 15. We want sine alpha plus beta, which is sine cos cos sine. If it's the sine, it's the sine. And we substitute in, just reading off the triangle and tidying that up, and we have an answer. 2 plus 5 root 3 on 12. There's the exact value. You go to a calculator on that, you're just going to get a huge decimal approximation. The tan of the inverse sine of 2/3 plus the inverse cos of 1/4. Remember, those inverse trigs are representing some angles. Again, we don't actually need to know what those angles are. So if I let alpha, this might make it a bit more obvious, if I make alpha that angle, the inverse sine of 2/3, again, draw up a triangle. 2/3, other side root 5. And I'll let beta be the inverse cos of 1/4. Draw up a triangle. 1, 4, other side root 15. Tan plus tan on 1 minus tan. I can now read off my triangles, substitute in, and a little bit of manipulation there, eventually we get it. There's an answer. 2 plus 5 root 3 over root 5 minus 2 root 15. Once again, that's an exact value. A calculator is not going to get that for me. So 17D is playing around with our compound angle formulas, so actually expanding the trig out.